Welcome everybody to this video on the product rule of radicals using exponents. So if you recall, we have this rule where we take the root of a number times the root of another number, and that's equal to the same thing as the root of those two numbers multiplied together. And this rule does go both directions. We can either combine two things under the radical, or we can split two things apart and then take the roots of either one of those numbers. So let's see how this works when we have an expression containing a radical with variables. So looking at this square root of y to the fifth power, we can actually break this down using the product rule of exponents. So if you remember, when we multiply expressions with exponents with the same base, we can add the exponents. Well, we can break this apart as well. So this can give us the square root of y squared times y squared times y. And if we add up our exponents here, we got 1, 2, 3, 4, 5. That's equivalent to y to the fifth power. And the reason I chose to break them down into squares because they are perfect squares and we're taking the square root. So if we break this apart again using our rule of radicals, we can break this down into the square root of y squared times the square root of y squared times the square root of y. Now, taking the square root of y squared, that leaves us with just y. Same thing with here, so we have y times y. And we can't take the square root of y because it's not a perfect square, so that just stays the same. So when we simplify it, then we multiply together our terms on the outside, giving us y squared times the square root of y as our simplified expression of the square root of y to the fifth. Looking down here, but now instead of a square root, our index is a cubed root. But we can do the same thing. We can break this down into perfect cubes using our property of exponents. So we have x to the third times x to the third times x. And of course, if we rewrite that, that's x to the third times x to the third, and then times x. And of course, our index on all of these is cubed root. We aren't going to change that. But the cubed root of x to the third power is just x. Same with this. And then we are left with the cubed root of x. And when we combine at the end, it gives us x squared times the cubed root of just x. So now it is simplified from the original expression. So again, use that product rule of radicals to your advantage to go both directions in order to simplify any expression containing a radical and variables.